Last section of chapter 7. Look, it took us 3 weeks, just chapter 1. Wow. Inequalities. Before we talk about inequalities, we have to talk about interval notation, that's one thing. Set notation, that's number 2. And operations with sets and intervals. Operations with sets and intervals. Okay. The interval notation, for example, x greater than 0. So this is number 1. Interval notation. How do I present this? Well, I can graph it on the number line, or real line we call it, and it's any number greater than 0 without 0. So the interval notation, we like to write x is in the interval 0 to infinity. So this is an example of an interval or interval notation. Another example would be, let's say, x between -4 and 10. How do I represent this? Whenever the inequality symbol has the equal symbol, I have to use a bracket, which is -4. Then I write a parenthesis. I write 10, comma, 10, and there is no equal symbol here, which means parenthesis. A parenthesis. Another example, let's say x less than or equal to -7. This means to the left-hand side of -7, but I have to read from left to right. So I will start with -infinity, parentheses for -infinity, comma, -7. I stop and see if it has an equal symbol, then I have to include it with a bracket. If it does not have the equal symbol, then I will use a parenthesis. So this is what we call the interval notation. Now, in number 2, the set notation, these are sets of elements or numbers if you want. This is one set. Let's say 2, 3, and 7. Here's another set. We normally denote them by uppercase letters. -7, -3, 0, 1. These are sets. And number 3, operations with these intervals and sets. The operations are one is called intersection, and the other one is called union. The symbol for intersection is an upside down U. That's the symbol. And the symbol for union is just a U. What do they mean? And then we'll look at examples. When we talk about intersection, we mean common elements. U and E. Intersection. Common elements. The union is all elements not duplicated. In other words, I will write them only once. Okay, so let's see how we apply this in different situations. Operations with sets and operations with intervals. Let's start with sets. And I'm looking at the problems in section 1.7. I don't see any example with sets, but I think it's important. I'll just show one example. So let's say we have A, -3, 0, 1, and 2. And let's say we have B, 5, 1, 5, and 10. 1, 5, and 10. If I want to determine the intersection of these two sets, I'm only looking for common elements. -3 is not in both, 0 is not in both, but 1 is in both. 2 is not in both, 5 is not in both, 10 is not in both. So this is the only element of the intersection. But if I want to create the union, then I have to write all elements in order from left to right, from smaller to largest, and only once, copied only once. So 1 will not appear twice. So it's -3, 0, 1, 2, 5, and 10. So this is the intersection, common elements, and this is the union. All elements are written only once. Okay, so let's see how we do this with intervals. Okay, so let's say 22 on page 202, -infinity to 6, and union 2 to 9. And you can say, I don't see this, and I will have to agree with you. This is not clear what I need to do. So I'm going to graph. 0 is always in the middle, -infinity to infinity. I will use blue for -infinity 6. I don't care for units. So I'll say this is 6. And the other one is, I'm going to use green for 2 to 9. Again, I don't care for units. Bracketed 2 and parentheses at 9. We're asked to determine the union. All elements written only once. So can anyone give me the final answer? So I don't have enough room here, so I'm moving here. What is the final answer? Very good. Very good. What if, this is not what we are asked, I'm changing the problem because I have the graph in front of me. What if I'm asked this? What will the answer be this time? Great job. Does everyone see that this is the common territory? This is the blue, this is the green. The only portion where I have blue and green at the same time is between 2 and 6. And that is the intersection. That means common elements. And now you can say this is wonderful, but when do we apply this? And I'm going to just give an example right away. I like to solve the linear inequalities, and then I will have an example like that. Oops, my green is growing legs. Okay, so let's first look at linear inequalities. And let's say 38 on 203, -4, parentheses, x plus 2, greater than 3x plus 20. So pretty much the linear inequalities are solved with some exceptions, of course, because we have other idea here a little bit. but we are solving them in the same way we solve linear equations. It's just that now we have the inequality symbol instead of the equal symbol. I have to distribute negative 4x minus 8 greater than 3x plus 20. Like we did before, nothing new. I will move 3x to this side and I will move 8 to this side. So when I move 3x that has a positive sign in front of it to the other side, it becomes negative. So then all of a sudden I have negative 7x. When I move negative 8 to the other side, it becomes positive. So I have 20 plus 8, which is 28. At this point, I know you're going to say that I have to divide both sides by careful. Very good. So the left hand side is nice and easy. The right hand side is nice and easy. But now I have to, oops. Now I have to, my other camera just grew legs for a second. Okay. So now I have to refresh my memory on something very important. If I have 2 less than 10 and I decide to divide by 2, that's fine. I still have 1 less than 5. But if I have 2 less than 10 and for whatever reason I decide to divide by negative 2, negative 1 and negative 5 are no longer in this relationship. They are in this relationship. So every time we divide both sides of an inequality by a negative number, we must switch the inequality symbol because this will no longer be true. So therefore, the solution in interval notation is from negative infinity to negative 4. So negative infinity to negative 4. Any number that is less than negative 4 will be to the left of negative 4. So this is how we solve linear inequalities. And the second type will be compound inequalities. That's a different type. And let's say 58. Same page, 203. Negative 6 less than or equal to 1/2 x minus 4 less than negative 3. Why is this called compound? Why is it compound inequality? Because as you see, I have one inequality here, and I have one inequality here. Like an equation, inequality cannot have two, a simple inequality cannot have two inequality symbols, right? We are not going to separate them into two inequalities because they are like a chain inequality or chain inequalities. So what we're going to do though is step by step get rid of everything and keep x in the middle, and once we get that get to that stage, we're done. So what do I need to eliminate first from here? Actually, I'm focusing on in the middle. What do I need to get rid of in the middle first? Yes, excellent. I need to get rid of 4. And I'm going to add 4 to all 3 sides. Add 4 to all 3 sides. When I add 4 to the left, I get negative 2. When I add 4 in the middle, I get 1/2 x. When I add 4 to the side, to the right hand side, I get 1. Okay, next step, what am I trying to get rid of? I'm solving for x. So I need one more step.
Do multiply by 2.
Excellent. We'll multiply everything by 2. Multiply all three sides by 2. Negative 2 times 2 is negative 4. 1/2 times 2 will be how much?
X.
Very good. And less than 1 times 2, which is 2. This is it. The solution is negative 4 with a bracket because of the equal symbol, comma, 2 with a parenthesis. And I like to put in front x in. X is a number anywhere you want between negative 4 and 2. You can pick any. You cannot pick 2. You can pick negative 4, but not 2. Any questions on compound inequalities? Any questions on compound inequalities? Just step by step, exactly the same. Last one and last topic of this chapter is absolute value inequalities. So you can pride yourself by knowing 8 types of equations, 2 more later, and 3 types of inequalities. What types? Linear, compound, and the last one, absolute value. Absolute value inequalities are of two types. The first type, something like this. This is an example. And the second type, something like this. It doesn't have to be equal to, it can be just greater than or less than. Okay, one is slightly easier than the other. Let's start with the easier one. What does this really say? It says find x values such that the distance between x and 0, these x values, and 0, which is this. This is the distance between x and 0. Is less than or equal to 3 units. Okay, I don't know where they are, but I'm going to graph. This is 0 in the middle, negative infinity, positive infinity. And if this were an equal symbol, how many solutions will you have if this is an equal symbol? I didn't see Max. I'm sorry, my apologies. I will look at it. So if this is the equal symbol, then we know, like from last time, that this is 3, negative 3 or 3. So the question is, where will I find solutions for this inequality? Where should x be? Should it be here? Should it be here? Should it be here? Anywhere, but just tell me where. Find x value such that the distance between x and 0, this is 0, is 3 units or less. I will find the solutions here, between negative 3 and 3. This inequality changes into a compound inequality. That's why we studied compound inequalities first. So whenever I have the absolute value of x less than or equal to 3, or any other positive number, I will get this answer. So between negative 3 and 3. So for example, 64, the absolute value of 3x plus 5 less than 17. It's exactly the same thing. I have to write that negative 17 is less than 3x plus 5 and is less than 17. It's the same type of inequality. It's just that here I have 3x plus 5 now, and here I have 17. I still have to have 3x plus 5 between negative 17 and 17. And now I already changed this inequality into a compound inequality, and I know what to do. What do I need to get rid of first? Very good. So I will subtract 5 from all three sides. Negative 17 minus 5, negative 22, less than 3x, less than 17 minus 5, which is 12. I have one more step to go, which is, and it's done. So I solved the inequality. It's an absolute value inequality. We divide everything by 3. So we get negative 22 over 3 less than x and less than 4. And that's the solution. X in the interval negative 22 over 3, comma 4.